Hello and welcome back to iPio's programming videos. Now I'm using the same. I'm using the same project. Actually, more coffee. I deleted the main function. Okay, so the main function. I think it's called from outside, so I think I need to make it public. Nah, it should be okay if it's internal. Don't matter. Public void doesn't have a well, technically it would have a return value, right? They return integers. Main need to hit the correct spelling on main because it's set somewhere. Is that actually? Let me check that. Is that in the assembly information? I could have sworn this is defined somewhere. Like it's like something like default entry point, startup object, not set. Why? Maybe it has to be named main, but it can have a different start because the startup object would be program, right? Public. Integer main, an array. Oh, we didn't go into arrays. String array args. So all the arguments that are passed in, get them over here. And then it can't be it can't be not static. It has to be static. Static. Are you complaining? Not all code paths. So this console programs are called from the console, from the command line. Command line programs are called from the command line, and they return 0 if there was no error. That's the absolute default. So on success you return 0. On not success, anything but 0. That's the default behavior here. Just to make that clear. And I think that's okay. Am I allowed to do that? Yeah, you have no issues with that. The alternative would be to use, I think, environment exit. Is it an environment exit? Yeah. And you can terminate with an exit code. And that's, if you use that, you kill everything. This is so hardcore. Because you crash everything that's running, even if it's a different program that's accessing your program, that you kill that with it. Just don't use that. Be graceful. Okay, what are we here for today? We're here for a class, actually. So there's a class already. We have a program class. This class has a static main method. I can still go ahead and say program P is new program. See, I can do that. This program up here is actually never instantiated. And an instance is like a copy of that. I can have a class. Let's make a class internal, and this is not an I. How did I write that? Was it Alt I? Control I? Oh God, I'm doing something. Escape. End this madness. Internal class like book. And now we have a book class, and we can have a book, like book. What's a good book? I don't know. I don't read books. Moby. Book Moby is a new book. I don't know. I never had a book. Book Alice in Wonderland is also a new book. And you can have like two copies of well, they're different books, right? They are different books in a lot of ways. They are not different by the content though, because right now they're both completely empty. Even if they were completely equal in the content, you would still refer to them as different books. Like this book can have a public integer a. Let's go year, public integer year. And Moby dot year is when was Moby Dick written? Wikipedia Moby Dick. I wrote Moby Dick. Okay, Herman Melville. Moby Dick. 1815 to 1851. So it's 1850. Let's say 1850. And Alice, when was that written? Alice in Wonderland book, Wikipedia. The Hatter. Appearance. Okay, I'm wasting too much time here. Let's close this. I'll just claim that it will be written in 2100. We're in the future now. It's gonna be the future soon. So now we have an Alice book that's from this year. Now we have the same Alice book again in the same year, just a different copy. It was printed twice. We have two copies of that in our bookcase. We can have a bookcase, and these are the books in our bookcase. You can see that we have the book Alice twice. The fact that the why we're using a class is because we want to express that this thing is its own thing, and if you do things to this, then you did something. If you remember, for the value types, we had an example. Actually, I wanted to add a toString method, but let's not do that yet. Let's go write book, and we give it Moby. Okay, now we need the private static write book, and we pass in the book. That's the parameter list B. Okay. Oh yeah, return value, because I don't want to return anything. That's why I keep forgetting it. I don't know. Write book B. So console dot write line B dot year. You just write the year. No, don't continue. It says there are errors in here. Oh, Alice isn't, the Alice.year is. Okay. Right. 1850, see? This was for Moby. We can write Moby, we can write Alice, and we can write the second copy of Alice that we have. Okay. We didn't set that. All right. Okay, so now we have two copies. Now, with a value type, if we pass it into a function and change the value and it comes back, because it is copied at the moment where it passes into the function, the original stays the same. With objects, and these are classes are objects, that doesn't happen. If we pass in the object, we're kind of not passing in the book, a copy of the book. We pass in the location in our bookcase where this book stands. So if I'm telling someone change the year, we're actually changing the year in the bookcase, right? So because we gave him the address in the bookcase where the book is, he walks up to the bookcase, takes the original book that we just gave him, opens it, changes it, and puts it back into the bookcase, and then it's changed forever. And that's what the difference between a value type and a class is. So in most cases, you probably want the changes to remain with the thing. So you probably want a class. You next to never want to write a value type, and that's actually a complete lie. Classes are typically made up of value types. It really depends on what you want to express. But just know this is a tool in your toolbox. So if you now go use black marker on year and pass in ls2. So we go to the bookcase, you use the black marker, and then we print them all again. Let's just print them all again. And we have to use black marker. It has a very similar signature. Let's just copy that and copy the name that we need. Okay. And now we go the book year. What does a black marker do? If we do that, actually let's override. Let's pass in the year. So we actually change the signature, and now we want the year to be over 9,000. Okay, so I don't need a program. That was just for demonstration purposes. Okay. White space actually doesn't matter, right? So the fact, we didn't talk about this, but I thought this might be implicit. The fact that there's a new line here doesn't matter. We can do that. Just for clarity's sakes, let me just completely screw up everything. Yeah, see? White space does not matter. You can make it look ugly as hell, and it's the same program still. Okay, and if you did that and you go Control A, you select everything, then you go Control K for a certain submenu, and then F for format, and then it prettifies it kind of. And then if you use extra programs like CodeMate, you can clean up. Okay, no, did not reintroduce the line breaks. I was hoping it would, but okay, you know what? Let's live with it. It's not. Oh God. Moby. Just hush. Okay, so the point is, we're creating Moby with a year, Alice with a year, Alice2 with a year. They're all in our bookcase. We print out whatever is in our bookcase now, because these references are object references which point to the bookcase. We go with a black marker to the original bookcase, actually change Alice2 inside of this thingy, and now it changes. If you print it again, it should print a different value. And that's what happens. 1850, 2001, 2001, 1850, 2001, 9001. Right? Because we changed it here, although we passed it into somewhere. And that's a difference. You need to know if it's a value type that you're passing in or if it's an object you're passing in. And the way to determine that is just always use objects. Then you know it's an object that you're passing in. never use a value type. So never use struct, and all of the other ones, the integer and these basic stuff, yeah, you're fine. So that's kind of how you know how to distinguish them. Because if I write a struct now, I could have written internal struct book also, and a year. Like there's visually no difference between book also and book. So if I make Alice 2 into a book also, I was thinking, yeah, this breaks a lot because they're now I'm changing the type. I'm changing the type of Alice 2, and so I can't, obviously this type is book also, not book, so I can't write new book and assign it to Alice. So I need to go make it a book also. It also has a year, so that did not break. I copy pasted that, so the year still stays the same, but I can't use the right book on Alice right now. The fix I'm going for here isn't the best one, but let me just copy these blindly. So now they exist twice with two definitions, and the compiler can see, oh, okay, so this function definition did not match, but you have this other definition which does match, so I'll use that one. This works for nearly everything. What's your problem? Oh, we're not using that one anymore. Okay, yeah, you're fine. Okay, now we're doing the same thing. We're doing the same thing here, where we override it, but we use a value type instead. So if you go and see that, it's working on a copy now, so it'll not update, right? We did not, before we said it's here in this bookcase, go and get that if you do anything with it. Now we're going, let me take this out from the bookcase, copy it for you, give you the copy, and you're working on the copy. This is precious. I'm not giving this to you. You're working on a copy. Yeah, this is what we said, but see, the thing is that you can't really determine that, right? They all look the same, if just by pure inspection. You see, this is a class, this is a struct, but they're the same pinkish color. So it's kind of hard to, with the default settings, to determine which is which. It makes a lot of sense to have to use the different methods available. The question is it, if the contents change, is it a different thing or is it the same thing? With a book, if I take a book that's in the bookcase and I smear black color into it and or rip out pages, it's still the same book. It has been modified, but it is still the same book, right? Although its contents are different now because I messed it up. If I have let's see, anything in the book. Yeah, if there is the publisher written into the book, right? The publisher itself, if the name of the publisher changes, this label on the publisher, if that changes, that's no longer the same publisher. So I change something, and then I would have a struct. So I can compare the publisher of two books, and if they are value equal, if the values of those are equal, then they're the same publisher. And if that's true, then that's probably better expressed as a struct. If I'm comparing two books and the contents of the books are different, they could still be the same book. Yeah, just maybe at a different point in time, for example. So I could have the Alice book 5 minutes ago where I didn't screw it up, and then I have the Alice book like 5 minutes later, and I can't, by comparing the content, I could say, well, this one has black marker in it and this one doesn't, but they could be the same book, right? They could be just the same book at different points in time. I don't know if that makes a lot of sense. Yeah, but it's if you can compare if things are the same, if you compare the values, then they are structs. If things are different, if things can be the same, even if you compare all the values and they are different, then they are classes. I hope this clears it up. God, I would not understand this. If anyone told me that as a beginner, I would not grasp what I'm going on about. How can I explain this better? Yeah, if you know, let me know in the comments below. For now, just use classes. Don't use structs. So as a beginner, just go classes. Go classes. There's one more thing that you can do with classes, and that's adding methods. So right here, this class has a method. It's not really a class method because anyone can call it, right? It's like console. Console is a class. Console.writeLine. WriteLine and myLine. I actually don't know if I can instantiate console. It could be, there could be something like that. There are a few keywords. New console. Can I instantiate that? There's some way? No. Yeah, I can't inherit and I can't instantiate it. Okay, but I can do that with program, right? Although program P equals new program. Ta-da! I instantiated program. Program is completely empty. This right here is, I know you can say it's inside of the program, but you can address it without having an instance of program, because this thing is on class scope, not on instance scope. So because of the static keyword, program dot main with my arguments, which actually have to be. Oh, we didn't cover errors yet. Just trust me. This creates an array of strings. Actually, can be empty. Doesn't matter. It literally doesn't matter. Okay, so this now I'm calling main inside of main, which is recursive. Let me show you how fancy that looks. Let's be recursive without an end condition. Yay! And we should run into a Stack Overflow. Like, it's constantly doing that. At some point, yeah, see, stopped working because we finally ran into a Stack Overflow. What it's doing here is recursively calling itself. The main function starts, writes on the console, and calls the main function, which means that the main function did not finish, so the computer needs to have a note because he wants to jump back, right? If I go into and write this console program, I go from main to the console program, write it out, then I come back to main and continue with the execution. So right here, I'm starting here, executing this, I come back to main, go to the next line and do that. And if you want to come back to some place, you need to know where that place was. And that place isn't only this line, it's also everything that was true at that moment. If I have an integer a here, integer a equals 5, and I want to write this integer a, this could have changed, for example, and oh, now I have a equals 7. So when I come in here, when I come into main, I get I get a new copy of a. Still need to remember that the a in the other main that I used has changed. So when I come back, although we know we won't ever come back, the computer doesn't know that. he keeps that A value around, because when we come back, we'll need it. For sure we'll need it. So he keeps that. That actually was not true all the time in programming. There are programming languages where this is just not true. It just works in the same copy, which screws up all sorts of things. But yeah, this for modern languages this is true, but he has to keep the whole context. So he keeps the context in memory, jumps out, does a thing, there's another jump point. So let's keep that in memory, jump out, do the thing, jump out, do the thing, jump out, do the thing, because he always assumes that you won't do that to me, I'm going to jump back, right? But you're never going to let him jump back. He will just run out of memory and crash. And that's what happens. And luckily, modern operating systems don't give you all the memory at once. Like if you want to have a big memory, a lot of memory, you need to take extra steps. They pay attention and just don't let your program grind out all the memory on the system. You crash before that, but yeah, it's a Stack Overflow. There's a limit. There's a limit how far you're allowed to go. If you want to go further, you can, but it's special. Okay. That's it for this jumping here. What I actually wanted to do is instantiate a class and write a method, because like main here is a method, but it's static. I should stop that. This is just a call. I just was demonstrating a call. So let's get a new class in here and call it internal class. Actually, let's go for book again. Book. And this time we'll have string author and string year. I want strings this time. Public. Okay, I'm saving the constructor, which would be important, but I want to do something, get some progress. Book B equals new book, and then author. Yeah, actually, let's have a constructor. My author, because I don't have any imagination, and the year is the year 2000. Okay, now he doesn't have a constructor that takes that. If you go control dot, you get the offer to create that. Created without the fields, yeah. And he doesn't know what to name this, so he just went for value 1 and value 2. But we know this is the author, and we know this one is the year. And now we go under dash over here and go author equals author and year equals year. And there is the autocomplete. You can actually help the autocomplete if you go, I could have gone string author equals my author, and then string year equals my year. Like at the very second that I wrote this, could have done that. And the end, I'm writing colons for some reason. It's obviously semicolon. So instead now we write author and year. And year. And year. Okay, and now we kill all the contents here. And he can't construct that because he doesn't know it. But because I now named it, he won't go version v1 and v2. He actually, you see in the preview, he does exactly what we wanted, except that he used this. Now this depends on what you have installed on your machine, and this is kind of the default installation. ReSharper would have done that correctly. And I want these to be public because I want to break encapsulation for now. We'll talk about encapsulation like next or something. Okay, Now I want to be able to go some version of console write line, and then B. I want to write that. What happens when I do that? It says demo app book. Now that's bad. Demo app is the namespace in, and this is the class. So what version is using? If you hover over it, it uses object. Writes the text representation of the specific object followed by the current line terminator to the standard. So current line terminator because it's write line instead of write. Okay, so it writes the standard string. Let's go and make a method. Yeah, I don't want to go into override, so that's why we're doing something slightly different. Make my string. And now we're going to write the method make my string. Now, an easy thing to output on the console is a string. So we just go string. And make my string makes a string. Note that I need to make this public because we could have gone for internal. Let's go for internal. Make my string needs to return something, return the string. Okay, so what we wrote here, note that this is not static. So because it's not static, I cannot go book dot make my string. Make my string. I can't do that, and he should tell me, is there a useful tip? An object reference is required for the non-static field method or property, so he doesn't know if it's a method or property. Loser. Make my string. Okay. Yeah, so, and the reason why he's saying that is because this is kind of the class, and it's the thing in here is non-static, so it's this thing in here, well, both of them. This is non-static. This is a constructor. This doesn't apply. It's non-static, so it needs a class to do it on. So this is why we're writing b dot do something, because this is the class. An instance. This is the class. This is the name of the variable we want to use right here, and this one creates an instance. So b is an instance of the class book. So you have the concrete instance, and this one works on the concrete instance. So we go b book. These over here, author and year, are also on the instance. They're not on the class. So what I can do here is in make my string, I can actually use author and year. So I can go author plus year or something, and return that because I can access these now because they're inside of the same class. And if I execute this, I'm getting my author, the year 2000. I didn't include spaces because I don't care. But yeah, so you can see how this, because that's the point here, is that this works on the instance and it uses the stuff inside. And you can kind of use author and year in here without directly accessing them. And this is also why you want to have classes, because now I can make these private. Private. So these are private now. It's not very easy to modify them. You can still do some hacky C# tricks to access and modify those, but you wrote the clear statement that you don't want anyone to access these. Those are yours and yours alone. No one should access these. Yeah, so that can actually be read only. Okay, b dot author equals something. I'm no longer allowed to do that. If you check that now, book author is inaccessible due to its protection level. Now, don't just go control dot. Oh, it doesn't do that here. Okay, if some tools allow you to just make this public now, there's a reason why you wanted it private. You don't want anyone to modify it. And there's actually there are additional properties that you can assign, and I'll look them up and go into detail on some of them. But for these, you only write them once. You don't ever, the year and the author you don't need to change, so you can make read only, read lonely, read lonely. I'm so lonely. I'm writing lonely again. Read only. Okay, so read only. You can write read only, and that makes it so that you essentially can only assign them in the constructor and never access them again. Yeah. So this is how you can make MyString. Book, there's a thing called inheritance, and all classes inherit from object. So if you go b dot, you can see that this thing has make my string, that's the one that we wrote, and it has more than that. It has equals, it has get hash code, has get type, and has toString. Now if you remember, equals on an object doesn't make sense really, because they could be equal if their contents are different. It's hard to explain why this is useful, but essentially if you have like a database and you have like a thing that you display on the screen, and then you have something coming in from a web application with regards to that, the versions on all these different sources could just be different. You could write something and read out a different state right now, and then you get notified, oh yeah, something has been written, so you just update that, and you get a different object with different contents. You're supposed to update the right object, but which one is it? So you kind of need a method to check for equality. And this equals right here, the default implementation that's inside of objects, just checks the reference in your memory. If these references are equal, they're equal. Similarly, get hash code, you can check equality using the hash code. Now, the hash code is, if the hash code is equal, it's just an integer, it's just a number, so very, very flat. If the hash code is equal, you're guaranteed that these two are equal. If the hash code is different, you don't know if they're equal. It's actually a good thing, it's very fast. Get type, this is something for the type system. You can use that for all sorts of fun. I barely leave house without type. The type system. So get type just gets you the type. So you can do that if you don't know the object. So let's make an object. This is called boxing because you're putting it inside the box and you have no idea what it is. But you can go. The type system still knows it. So you can go object get type. And at runtime, you can check what this type is now. There are better ways to get that, but you can kind of read the type out of the object. And it won't tell you I'm an object, it will tell you I'm the book. So that's another one that's already there. Make MyString is the one we wrote, and there's a toString. And this is object toString, and the default one is it goes namespace and type. So it essentially gives you kind of the type information, what this thing is. It's better than nothing, but it's not great either. So what we want to do is use that for MyString, because when we wrote WriteLine, we actually don't want make MyString. We want to go WriteLine B, for example. And we know that it'll try to use MyString. So what we want to do is change this implementation of the MyString. And you can go and override the base implementation, and it should give us, the autocomplete helps you with writing that, and so it has to be public because the previous implementation is also public, and it has to you need to use the keyword override to tell them when to override the base one. Now you can still call the base one, and it has a base because you don't see it here because every class is inheriting from object. Every class is an object. This would how you write inheritance. It makes no sense because it's there anyways, so that's why it's underlining. But instead of returning that, we return what we wrote here. And now we no longer need this function because we're using toString. There are other reasons to write functions like that. And here's the write line now, and it writes out the thing. And that's another important aspect of objects, and that's polymorphism. And the thing about polymorphism is if you can get to a place without using polymorphism, don't use polymorphism. Okay. Right. So that's it for that. Next time we'll go into details of what you can and cannot do with objects. Probably only what you can do. And maybe a stern warning of things that I think you shouldn't do. Yeah. Maybe we go into interfaces. I don't know yet. Let me know in the comments below what you'd like to hear next. God, it has been 40 minutes again. Way too long. Sorry for the long time. I'll try to be shorter next time. Thanks for watching. Bye.